Hi everyone, welcome to welcome to my another lecture on Cauchy's integral formula for derivative of analytic function. So in this lecture, the learner will be able to understand the how to apply Cauchy's integral formula for derivatives. I will do here in this lecture two sums using Cauchy's integral formula for derivatives. This is example number 2. So this is the actually Cauchy's integral formula for derivatives. That is, this formula I proved in my previous lecture, that is lecture 1, for Cauchy's integral formula for derivatives. So this is lecture 2 of Cauchy's integral formula for derivatives. Okay. Use Cauchy's integral formula for derivative to evaluate this, where C is the circle, that is mod Z equal to 3. Okay. So this is second sum, and another sum I will do in this lecture. Okay. Let's see. This is university question paper, very important sum. So with this sum, first of all, you have to see whether C is a circle of mod Z equal to 3. When mod Z equal to 3, that means this is a circle with this represent mod Z equal to 3 represent a circle whose radius is 3, center is 0, 0. Radius 3, center 0, 0. So I am just, this is a circle, whose center is 0, 0. Radius is, this is 3, 0. 3, 0. This is a real axis, this is imaginary axis. Okay. So this point is 0, 3. 0, 3. Okay. Center 0, 0, radius is 3. So after getting this case, what will you do? You have to find out the singular points. How to get the singular points? To get the singular points, we put denominator portion is equal to 0. To get singular point, put Z plus 1 is equal to 0. This is also called pole. Okay, pole of order 4. Okay, so Z equal to minus 1. Z equal to minus 1. Okay, so this circle just I am showing here. Okay, Z equal to, you see this. So Z equal to minus 1, that means we can say this equal to, that is Z0 equal to minus 1. So this can be written as, minus 1 plus 0 into I, that is minus 1 comma 0. So now we have to check after getting, this is the singular point. For this point, this is not defined. So this is known as singular point. What is singular point? Singular point is that point such that the whole function, this is the function, whole function is not defined. That is, this function is not defined when Z plus 1 is equal to 0. So this is known as singular point, or you can say pole of order 4. Okay. So after getting the singular point, you have to check whether this is inside the circle or outside the circle. Okay. So now we are checking minus 1 comma 0. This is 0, 0. This is 0. This is minus 3 comma 0. This point. So this point is actually minus 1 comma 0. So minus 1 comma 0, we are getting minus 1 comma 0. Just I am writing over here. This point inside the circle. This is actually minus 1 comma 0. Minus this point inside the circle lies inside circle. This is the closed curve. like inside C, closed curve C, or you can say inside the circle. Okay, inside the circle. So this is inside the circle, that is z0 is equal to -1 inside the closed curve C. Then by Cauchy's integral formula for derivative. This is the Cauchy's integral formula for derivative. So using this formula, what is fz here? Fz equal to e to the power 2z. Fz is equal to e to the power 2z. Okay. Now the question is, why we are applying here Cauchy's integral formula for derivative? Because you see that to see the sum, the denominator power is 4. 2 or more than 2 when the denominator, that is function of z, that is z plus 1 is power is 4, more than 2, 2 or more than 2, then we have to apply Cauchy's integral formula for derivative. Then by Cauchy's integral formula for derivative, to get this is 4, what we have to put? N equal to 3. You see, this is the formula for Cauchy's integral formula for derivative. So if we put N equal to 3, that means F3Z0. That means F3Z0 we need. Okay. So F dash Z0, F dash Z is equal to 2 e to the power 2z. F double dash Z is equal to, that is 4 e to the power 2z, and F triple dash Z is equal to, that is 4 to the 8 e to the power 2z. Okay, that is F triple dash, that is, you can see F triple dash Z equal to what? That is -1. F triple dash -1, this equal to 8 e to the power -2z, Z0, Z equal to -1, this is -1. So I am putting here Z equal to -1, that is 8 e to the power -2. Then by Cauchy's integral formula for derivative. Cauchy's integral formula, then by Cauchy's integral formula for derivative, I am just removing this part. This is the Cauchy's integral formula for derivative. So using this formula, so what will you do? Just I am putting, that is, what is fz? E to the power 2z. Just putting C here, e to the power 2z by z minus, what is z0? Z0 is equal to, z0 equal to -1. That is z plus 1 whole to the power n equal to 3, that is 4 dz is equal to 2 pi I by factorial 3, because n equal to 3 I am putting. Okay. So now f triple dash 3, n equal to 3 means triple dash. What is z0? Z0 is -1. So just putting over here 2 pi I by factorial 3. Factorial 3, you can write factorial 3 is equal to 12. 3 to 6, that is 6. 2 pi I by 6, here is e to into 8 e to the power -2. Now after simplifying, this answer will become, that is 3 here. So this 8 by 3 pi I e to the power -2. This is the answer. Okay. This is the answer. Okay. So I think everybody understood very clearly. So I'm going for next sum, actually. What is the next sum? Next sum also using Cauchy's integral formula for derivatives. Okay. Using Cauchy's integral formula for derivatives, how to get this? This is the formula. Next sum I am writing over here. You just follow me. This is Cauchy's integral formula. So example number 3 now. This is example number 3. So evaluate cos qz by z minus pi by 4 whole to the power 3 dz, where C is the circle, C is the circle, C is the circle, mod Z is equal to 1. This is also important sum. This is equal to very important sum. Now, to see this sum, the question is, what should I apply Cauchy's integral formula, or should I apply Cauchy's integral formula for derivatives? Cauchy's integral formula for derivatives. Which formula we have to apply? Cauchy's integral formula for derivative. Why? Because denominator is the power, that is z minus pi by 4. This power is 3. When this power is 1, then only Cauchy's integral formula. If it is 2 or more than 2 power, then we have to apply Cauchy's integral formula for derivative. Okay. Okay. Now, what I told, after seeing the sum, we have to see that is mod z equal to 1. So this is a circle. This is a circle of center 0, 0. Radius is 1. This is a circle. You have to draw this center. This is 0, 0. Radius is 1. This is 1, 0. Okay. This is real axis. This is real axis. This is imaginary axis. Okay. So now, after getting this, this is control. This is C, closed curve C, closed curve. This is a closed curve where C is a circle. This represents a circle. Why? If we put z equal to x plus iy, then mod z equal to root over x square plus y square. So mod z like this way, x plus iy z, then equal to 1, that is root over x square plus y square is equal to 1. Squaring both sides, then we are getting x square plus y square is equal to 1. So center is 0, 0, radius is 1. Okay. After getting this, what will you do? You have to find the singular point. That is, for what values of z, this function is not defined. This function is not defined. That is known as singular point. Okay. So if we put, that is to get the singular point, singular point, always you put z minus pi by 4 whole to the power 3 is equal to 0. Denominator part is equal to 0. That is z equal to, that is pi by 4. Okay. Z equal to pi by 4. This whole thing is not defined. So this is the singular point. As singular point, we are denoting z0. So z0 is pi by 4. So this can be written as pi by 4 plus 0 into I, that is equal to pi by 4, comma 0. So this is the singular point. That is pi by 4, comma 0. What is pi? 3.14. So 3.14 by 4, comma 0. That is 3.14 by 4. That is less than 1. Okay. So less than 1. So this point, say, this point that is 3 pi by 4, comma 0 lies inside the circle. That is because this is less than 1. That is point something, comma 0. Say this point is pi by 4, comma 0. This point is pi by 4, comma 0. Okay. This point. Okay. This point. That is inside circle. This point lies inside circle. Inside the circle C. Inside circle C. Or you can say inside the closed curve C. Inside the closed curve C. Okay. So when it is inside the closed curve, that means after getting singular point, you have to check whether this point lies inside the closed curve or outside the closed curve. This is very important. If outside the closed curve, then whole integration part will be 0. If inside the closed curve, then we have to apply Cauchy's integral formula for derivative. Then by Cauchy's integral formula for derivative, this is the formula. What is fz here? Fz equal to, see, fz equal to cos qz, which is always analytic function. Fz is equal to cos qz, which is always analytic function. Okay, because cos z sin z is always analytic. So this is always analytic function. So now we need what we have to put n value by Cauchy's integral formula. If we to get the power is 3, that means if we put n equal to 2, that is f2z0, f2z0 we need, that is f double dash 2, f double dash 2. Try to understand. So fz is there. What is f dash z? Is equal to 3 cos square z into minus sin z, minus sin z, minus sin z, and f double dash z, f double dash z, f double dash z, that is equal to 6 cos z. U into v I am doing 6 cos z into sin square z minus 3 cos qz, cos qz. Okay, okay. Now what is f double dash? What is z value? Pi by 4. That is z0 is pi by 4. F double dash pi by 4. That is 6 cos pi by 4 sin square pi by 4 minus 3 cos q pi by 4, cos q pi by 4. So if we put this value 6 into, you see, 6 into 1 by root 2 into 1 by 2 minus 3 into 1 by root 2 whole square. Okay, okay. Yes, so you are getting, that is 3 root 2 by 4, 3 root 2 by 4 you are getting, that is f double dash pi by 4. Okay, now by Cauchy's integral formula for derivative, Cauchy's integral formula for derivative, I think everybody understand this part. This is very simple, like differentiation. First f dash is z, we differentiate with respect to z, then f double dash z, then f double dash pi by 4. Because pi by 4 is the singular point, okay, which lies inside the closed curve C. Now I am just removing this part. So now by Cauchy's integral formula, you have to write this part. By Cauchy's integral formula for derivative, that is this. By Cauchy's integral formula for derivative, that is, I am just putting integral C. If what is fz? Cos qz, and here z. What is the value of z0? That is pi by 4. Z minus pi by 4 whole to the power 3. 3, that is n equal to 2 I am putting. Okay, n equal to 2 I am putting. That is 2 plus 1 you can write. Okay, that is 2 pi I by factorial 2 into f double dash pi by 4. F double dash pi by 4. That is 2 getting cancelled. So pi I into 3 root 2 by 4. 3 root 2 by 4. That is, answer is 3 root 2 pi I by 4. This is the answer. This is the answer. This is the answer for this integration of this. Okay, this is dz. This will be dz. Okay, this is the answer of this sum. Very easy. So what will you do first? To see the sum, you have to draw a that is a closed curve. Then after getting closed curve, you have to do you have to find the singular point. Then you have to check whether this singular point lies inside the closed curve or outside the closed curve. If the closed curve is inside if the singular point lies inside the closed curve, then we have to apply Cauchy's integral formula for derivative. Why Cauchy's integral formula for derivative? Because denominator the power of z minus pi by 4 is more than 2 or more than 2, then we have to apply Cauchy's integral formula for derivative. So this is the answer. I think everybody understood very nicely. So keep watching, sharing, commenting this lecture with your friends. Don't forget to hit the subscribe button and notification bell to get the update. Okay. Next, I'll come to my another lecture. That is lecture number 3. 2 or more sums of Cauchy's integral formula for derivative. Very, very important sum. I'll come with my next video. Very, very important sum. Don't miss that lecture. Till then, bye bye. Thank you.